Uh, Welcome back, learners. So, in our previous lecture, we were discussing about preparing the Excel sheet for designing the uniaxial, okay, loaded columns, right? So, this is the Excel sheet that we have prepared for the design of the uniaxial loaded columns. Now, along with that, we have learnt that how to obtain the values of the column, that is once the analysis is done, how to get the column loads and the column moments. And since we are designing for the axial load and the uniaxial moment, so out of the two moments whatever we have, so we have taken the highest moment. So in the next videos we will learn how to design the column with the biaxial loaded columns. That means when you have two loads, when you have two moments and one load. So here this is the load for which the given column is designed, and this is the load for which the given moment is designed. Okay, so now here before we move on to this, so what we can do is we can easily make the columns grouping here itself if it is required. Okay, so what we can do, either we can do the column grouping here or we can do the grouping later, right? So therefore better what we can do is here we will do the grouping later, because the moments values are of different in nature, or we can make the groupings here itself. So let us try to make the groupings. So first let us take the columns of the highest loading. You can see this is 1036, then you have 1124 and 1026. These are the three columns of highest axial loads, and what is their corresponding moments? It is 22, okay, and it is 127 and 130, right? So therefore we cannot make it as a single design, because the moment of this column is very lower, whereas compared to the moment of this column 12 and 13. Okay, so better, therefore, since we have two values to be compared here, so we will do the designs first. So once the designing is done, then based on the design results, let us do the grouping. Okay, yes. So now let us go for the design now. So according to that, we will start with the column number 1. Okay, so we'll start with column number 1. I'll give column number as 1, right? So what is the axial load that we have? The axial load is 521. So let us make it to 550. Okay, so let us make it to 550, and the moment as 50 kilonewton meter. Okay, so the load is 550. Okay, so the grade of concrete that I am going to use is see, as we already discussed, we are going to use the same as that of the footing. So for the footing, I think we are using the grade. Let us see what grade of concrete we are using for the footing. Yeah, so let us see what grade of concrete that we are going to use for the footing. Yeah, yes, I think we are using the grade of 30. So we are using the grade of 30. So therefore let us use the same grade for the column also, of the grade of concrete for the column 30, right? Yes, and we have 3 dimensions of the columns. Okay, so we have 3 dimensions of the columns, right? Yes, so we have 3 dimensions of the columns. So what we will do is let us make that all the columns of the same dimensions for the initial design. Okay, let us make all the columns of the same dimension for the initial design, and later we will change corresponding to the column dimensions what we have from the ETABS software. Okay, so like that we will do it, right? Yes. So the shorter dimension of the column we will keep it as 230. The longer dimension of the column we will keep it as 460. So let us change it. So first let us design for all the values. So then by looking into the ETABS software, so let us find out what is the column dimensions of the each and every column. Okay, what is the column dimensions of each and every column, and let us change accordingly here. So therefore here, as we discussed, the axial load we are going to give 550 and the moment is 50. So axial load we are giving 550, that is 550 kilonewton, and the moment at the base we are giving 50. And as you know, the effective cover that we always give to the column is 40 only, so no change in the effective cover. So therefore your d dash by d is 0.09 and your mu by FCK BD is 0.03. right? If you change, you can come to know that it will change. So therefore it is mu by FCK BD is 0.03, pu by FCK BD is 0.17, mu by FCK BD square is 0.03. And you know, for this uniaxially loaded column, your chart number varies from chart 27 to 59. So now we are using the grade of concrete 30 and we are using the reinforcement on all the four sides, and we are using the rectangular columns. Okay, the rectangular columns, reinforcement will be provided on all the four sides, not two sides, it will be provided on all the four sides reinforcement, and we are using Fe415 grade of steel. So therefore you can see that it is all of 250. So let us go to Fe415. Yes, from here Fe415, and we have to go to the reinforcement to be provided on all four sides, because we are providing reinforcement only, this is with respect to two sides, so we need reinforcement on all four sides. So therefore let us go to Fe415 reinforcement four sides. So our d dash by d value, so your d dash by d value is 0.09, it means it is nothing but almost 0.1. okay, it is 0.05, it is 0.1. okay, we are supposed to choose this graph. And what is the value of mu by FCK BD square is 0.03 and 0.17, right? So it is 0.03. okay, it is 0.1, it is 0.02, you can say 0.04, and it is 0.17. okay, so you are getting almost 0.17 is somewhere here. So that means according to this, no reinforcement is to be provided to be required, but no, so this is 0, let us take 0.02. okay, so let us take 0.02. the reason why we are getting like this is the moment at the base of the column is very small. okay, the moment at the base of the column is very small, so that's why you are getting mu by FCK BD square is very less. okay, so that's why we are getting like this, right? Anyhow, we will change according to the reinforcements of the column also, we will change, no need to worry, we will change. So once we will get the designs for all this, then just by changing the value of your column dimensions and just by changing the value of these two, again the design can be done very easily because it is an Excel, right? So I am giving the P by FCK as 0.02, so therefore my percentage of steel is 0.6. so you know we have to minimum provide 0.8%, so therefore this is my 0.8%. so this is my area of steel, I am using 16 mm dia bar, I am getting area of reinforcement of 1 as this, so total number of rods is 4.2. so we cannot give the odd numbers or the fraction number, therefore I will round it off to the next higher number, that is 6. Then lateral reinforcement, so that I am going to use is 10 mm, so therefore the least lateral dimension I am going to get, so 230, then 16 times the dia is this one, 16 times the dia of the main reinforcement, 48 times the diameter of the lateral reinforcement, then 300 mm. out of this I am supposed to choose the minimum, so I have choose the minimum of this, so that is 230. I can provide the final spacing as 200, right? Yes, so therefore this column number 1 is done. Then next let us go to the column number 2 of 1036. I can give 1050 and moment is 25. 1050 and 25 I can give, so that is 2. okay, so this will be 30 only, this will be 230, 460, this will be 1050 and the moment is 25, and this is 40, So therefore I can get the value, that is your d dash by d will be, it is 0.9 only. So your mu by fck bd will change, it will come to 0.02. So pu by fck, it will come to 0.33. Okay, so therefore let us see this 0.3. Okay, so 0.3 it is. So what is your value of this? It is d dash by d is 0.9, that means 0.1 only. It is 0.3. So 3.2, it is 3.3. We can go to 3.4. So in that 3.4, okay, sorry. Yeah, in that 3, this is 0.3, 0.32, 3.4, and what is your pu by fck bd? It is 0.17. I can go to 0.18. So 0.18 is here, and this I can go here, it is almost 0.28. P by fck is 0.28. Okay, so P by fck is 0.28. Okay, so P by fck is 0.28, percentage of steel will be 8.4. Just look into that, the percentage of steel is 8.4. that means it is not at all possible, you know, as per IS 456-2000. Okay, IS 456-2000, the maximum percentage of steel that you can provide for a column will always be between the 4 to 6%. Okay, but here you are getting 8.4. Let's check it here. Okay, so it is not possible. So it indicates that, so what I have to do is I have to increase my dimensions of the column. The only way is I can increase the dimensions of the column. Okay, since the load is a very high axial load, I have to increase the dimension of the column, right? So when I increase the dimension of column, then only it is going to work, right? So therefore what I will do, so I'll increase the dimension of the column. So that is, let us make the longer dimension of the column as, let us make it as 600 mm. Let's see. So when I make it 600 mm, d dash by d becomes 0.07, right? So then your mu by bd becomes 0.01, p by fck becomes 0.25, right? 0.2. So 4 to 4 it is here. And what is your value of that is 0.01, mu by fck bd square will be 0.01, that is somewhere here. Okay, 0.01, therefore you can say that value comes out to be 0.18, 0.16. Okay, it is come up to be 0.16. So therefore you can see I can make it as this will be as it is 460 only. Yeah, so this one, so I am making it as 600. So therefore automatically this will, everything will change, and this becomes 0.16. I am supposed to give the value. So therefore now what will be the percentage of steel? You can see 4.8%. okay, it is somehow manageable. So therefore I can give the actual percentage is 4.8 only. I'll give, and I'll get the total area, and I'm going to use the 16 mm. So definitely if I use 16 mm you will get more number. So let us go to 20 mm diameter rods. Therefore when I'm using that, I'll get the value, and what I'll get the total number of 21 bars, right? So I have to make it to 22. Okay, yes. Then what about this? So the diameter of the lateral ties, let us give of 12 mm diameter. Okay, and therefore what will happen to this? So this will be 230 only. So this will be 320, this will be 574, and this will be this. So the least will be 230. So let us give 200 mm spacing. Okay, yes. Yes, so that is about column number 2. Okay, since the axial load is very heavy, so this comes out to be like this. The next you have, it is 518, I can make it to 520 and this as 56, 520 and 56, right? I can make it as axial load 520 and I can make this as 56. So this will be anyhow 30, this will be 230 and this will be 460. Okay, this will be 230, this will be 460. Effective cover will be providing we are 40. Okay, so therefore let us see what is the value. It is 0.09 and mu by FCK 0.04 and it is 0.16, right? This is 0.16. So 0.16, 0.04, 0.1, this is 0.1, 0.12, 0.14, 0.16, 0.16 and 0.04. Okay, that means somewhere here. So that comes out to be between 0.06 and 0.08. So let us go to the 0.08 value. So that will be 0.08. Okay, so therefore what will be your percentage of steel? 2.4. It's well and good. So therefore the actual percentage of steel will be 2.4 I am supposed to provide. Okay, this will be 2.4 only, it is within the limits. Therefore I can calculate this value and I am using the 16 mm diameter rods. Then therefore I will get this value. Yes, I am getting, yes, almost 12 I am getting. I can give it to 14 numbers. Okay, I can give it to 14 numbers. Okay, yes. Yes, so that is for column number 3. And what about this? I am giving the diameter of 10 mm. So therefore I can give this. You are getting 230 means I am going to give 200 only. Okay, so this will be my dimension. That is about column number 3. Then next you have column number 4 of 475. So let us make it as 480 and this as 85. 480 and 85, right? 480. So 480 and this as 85. Okay, this anyhow it will be as usual 30, 230, 460. This will be 40 only. I can bring this. So I am getting 0.15 and 0.06. 0.15 I can bring it to 0.16 only and you have 0.06. Yes, so 0.0246, it is coming around 0.08 and 0.10. Let us go to 0.10, right? So this is 0.10 value. Okay, so therefore what will be your percentage of steel? So it will be 3%. So I am going to give 3 only. Okay, so it will be 3 only, right? Yes, so I think this is one which is calculated. Okay, so let us make it black. Yeah, 3%. So therefore what is the area of the steel that you are going to provide? I am going to provide 20 mm diameter bars only. So therefore what will be my total area? And I am going to get 10. So therefore I can provide 12 bars. And what about this? So I am going to provide the 10 mm lateral ties. Therefore you can see I'm getting the least is 230, therefore I'm maintaining 200. This is for column number 4. Okay, this is for column number 4, right? Yes, so this is for column number 4. Next, column number 5 you have, it is 903. I can make it to 910 and 70. I can make it to 910 and 70. So this will be 910, this will be 70. This anyhow it will be 30 only, 230 and 460, no change in that. Okay, so this will be anyhow cover of 40. So therefore it will come 0.09 itself. So 0.5, it is 0.29. You can see that again the load is heavy. So therefore let us make the column 600. Here itself let us make the column 600. So when I make the column 600, it is 0.22 and 0.03, right? 0.22 and 0.03, I can make it to 0.04. It is coming between 0.16 and 18. So let us give it 0.18%. So this will be 0.16%. Let us give 0.16. So therefore my percentage of steel will come around 4.8. So and I am going to provide the percentage of steel as 4.8 only. Then when I calculate this, so this will be, I am going to provide this, let us make it as 16, no issues. 16, yeah, I'll make it as 16 numbers. Then here supposed to provide 20 numbers. So therefore the area of steel will be this much. So you need 22 bars. Okay, so this is the same of this design, and here also I am going to provide a 12 mm, and so I am maintaining 200 only. Okay, yes, so that is of this column. Then next you have it is 646. I can make it to 650 and 55. 650 and 55. 650. Okay, 650 and 55. So this will be 30, 230 and 460. Okay, 230, 460, and this will be anyhow 40, right? So therefore when I calculate, so this 2 you will get it, right? You are getting 0.20 and 0.04, right? 0.20 and this is 0.01, 0.02, which is actually between these two, that is 0.14 and 0.16. So I can go to 0.14%. Okay, I can go to 0.14. So it is 0.14. So therefore your value of percentage will be 4.2. I am providing 4.2 only. So my area of will be this. So I am providing 20 mm. So my area of each bar is this. Therefore number of bars you will get it 15. So I cannot provide 15, and let us provide 16 bars, right? And here I am going to provide 12 mm only. So this will be this. So let us provide 200 mm. Okay, that is column 5 and column 6. So this column 7, column 8. Okay, this is column 6. So next you have is column 7 of 635. Let us make it 635 and 40. 635 and 40. So let us make it 635 and let us make it 40. So the cover is also 40. So these three will be same. Okay, so these three will be same. Yes, so yes, so this one here, here 0.20, so you are getting, yeah, so what is the load here, yeah, 0.20, 0.03, right? So 0.20 and 0.03, it's somewhere here, so that will come between these two, that is 0.14 and 0.16. I am providing again 0.14. Okay, so 0.20, right? Yes, 0.20, it is 0.14, so I am providing 4.2 only, 4.2. so this is my area, so 20 mm only I am providing, so this is the steel, so this is the numbers, so I am providing 16. Similarly 12 here, and this anyhow when I do this same, so minimum will be 200, right? Yes, that is for column 7. Then next you have column 8, we can see 530 and 30. Okay, so let us give the value 530, right? 530 and the value 30, right? So this anyhow I will be maintaining the same, so therefore this also 40 I am going to maintain. So you can see this will be 0.09, but these two will change. It is 0.17 and 0.02, 0.17, right? 12, 14, 16, 17, I can make it 18, 18 and 18 and 0.02, right? 0.02. Okay, so 2, 4, 6, 8, 0.02, so it is between these two, that is 0.10 and 12, so let us give 0.12%. Okay, so let us give 0.12%. so when I calculate this, it will be 3.6, no issues. So so I am going to provide 3.6 only, right? So then this will be my area, I am using 20 mm, so this will be the percentage of steel, so I am getting 12, I can provide 14 bars. Okay, I can provide 14 bars. Let's see, let us do the design and let us do it. We will come to know. Initially we will do, then only we will get the idea. So I am maintaining the 12. Okay, so this will be my reinforcement, and I am providing as usual 200. Okay, yes, so 9, 10, 11, 12, so that is my column 8. Okay, yes, so the next you have is column 10, right? It is 495 and 70, 495 and 70, so this is 495 and this will be 70. Okay, so these things will let us keep as it is, so this is also same. Now when you calculate this, you are getting 0.16 and 0.05. okay, 0.16, 0.16 and 0.05, 0.05, it is coming almost 0.10. okay, it is 0.10%, it is a 0.10. so therefore when I calculate, you will get percentage as 3, so I am providing 3%. yes, so this much value let us provide of 16 mm, so this will be the area, so the number of bars will be 15, I can provide 16 bars. Okay, so here I will be providing 10 mm diameter, So when I do that, I'm getting 200. Okay, so that is my column 9. Okay, so this is my 9th column. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And my column number 10, you have 4, 45 and 50. We can make it 445 and 50. So let us make 445. Okay, yes, 445, and let us make 50. Okay, so these three will be given here. So this will be here. So this will be 0.14 and 0.03. 0.14 and 0.03. So this will be of 0.08%. Okay, so this will be of 0.08. So that will give you how much? 2.4. I'll be maintaining 2.4 only. So 16 mm I am maintaining. This is my area of 1 bar. So this will be the number of bars. I'll provide 14 bars. So here 10 I am providing. Then this anyhow it will be same. Okay, it will be same. I'm providing 200. Right? Yes. So that is this. Then next you have column 12. So this is again very high. You can see that it is 1130. I can make 1130 and 130. Okay, so 1130 and 130. Definitely we have to increase the column dimension. So this will be 1130 and this will be 130 the moment. So this if I keep as it is and if I make this as 40, so I'm going to get the value 0.36 and 0.09. Definitely I have to make this as 600. So it is 0.27 and 0.05. 0.27 and 0.05. You can see 0.27. Okay, and 0.27 and 0.05. Okay, 0.05. 0.05, it will come around 0.18. Okay, it will come around 0.18. okay, which is of higher, very large dimension. So it is of 0.18 means what is the percentage that I am going to get? I am supposed to check. It is 5.4. it is very difficult. Okay, so let us what we will do, we will make this column of larger dimension like this. Let us make it as 600 by 600. Okay, or let us make it as 400 by 400. Let us make this as square column, but I know this is practically impossible. So once we do all the design, then we will finalize the column dimensions. Okay, so we will finalize the column dimensions, because all these are rectangular columns and this I am providing a square column. It is not right. For the sake of design purpose I am doing. So later we will finalize the columns, okay, by looking into the column positions in the ETABS. So I am making 400 by 400. So when I make 400 by 400, it is 0.24 and 0.07. okay, 0.24, 0.24 and it is 0.07. I can make it to 0.08, which comes out to be again 0.16% only. Okay, 0.16% only. So 0.16, right? If I make 0.16, okay, somewhat okay, 4.8. If you make 600 by 600, it will be more convenient. Let's see. So it will be 0.10 and 0.02. okay, 0.10 and 0.02, that will come, okay, 0.02, that will come around 0.08%. okay, so that will be 0.08. let us do like this and let us see what to do. So 0.08%, okay, 0.08. so therefore here 2.4, I can maintain 2.4. so this same thing I can bring, maintaining 16. Okay, yeah, so your so I'm supposed to provide of 20. If I provide 20, not possible, I can provide 32. So when I provide 32 mm, I can provide a 12 number of columns. So definitely it is very difficult. So let us see, because based on the positions of the column, okay, based on the positions of the column, so we may get that value like that. Okay, based on the positions of the column, we are getting that values. Okay, so therefore let us see, once we do all the design, let us see how it is going to be. Okay, and this anyhow I'm going to provide a 12 only. So when I provide a 12, I will get of this value, and this anyhow I'm going to maintain 200. Okay, yes, so this will be my this. Even the next is also, it is same as that of this. Okay, but the moment is higher, I can make it to 10, that is 1030, and this as 130. Okay, so 1030 and this as 130. So this, let us make it as 1030 and this as 130. So this will be 40. So let us make it as so doesn't work, so let us make it as 400 by 400. So this will be 30, and when I do this, I'm going to get the value 0.21, 0.07. Okay, 0.21 and 0.07. we are getting point again 16%. You can see you are getting again 0.16. so 600 it is 0.10 and 0.02, same, we will get 0.08%. so that will be 2.4. so I'm going to provide 2.4. so this will be the area, so 32, this will be 1, so this will be the number as 12, right? So yes, once we do this, even by looking into the design or the positions of columns, we will finalize it. So this is the preliminary designs that we are going to do. Okay, yes, so this is column number 12, that is this one. Then next we have 485 and 14. Okay, so let us make it as 490 and 15. Okay, so let us make it as 490 and 15. 490 and 15. The load is very less, so this I'm making 30 only. So this, let us see. Okay, so this will be 40 will be maintained, so therefore this will be 0.15 and 0.01. 0.15 and 0.01 means somewhere here, which will come down to be 0.10%. so it is 0.10. okay, so when I do that 0.10, you will get 3%. I'm going to provide 3%. so the percentage of steel will be this one. I can go to the steel of 20 mm diameter, so this value I'm going to get this. I'm going to provide 12. okay, here 10 mm stirrups, providing 200. okay, that is column 13. so then next you have 520 and 25, right? 520 and 25. so let us make 520 and 25. so the same thing I'll be maintaining. so this same thing, I'm getting 0.16 and 0.02. 0.16 and 0.02, which comes out to be again 0.10 only. So it is 0.10. So 3%, I'm going to maintain 3, right? So this will be this. So 20 mm, I'm going to maintain 12 numbers, right? Okay. So then here I'm going to provide 10 mm diameter. This anyhow same 200. Okay. Yes. So that will be this value. Then next you have 550 and 45. Let us make 550 and 45, right? So 550 and 45, right? Yes. So we will be maintaining this value. Then next you have is sorry, this is 40. Okay. Yes, this is also 40. So when I do this, I'm getting 0.17 and 0.03. So it's almost to be the same as 0.10. So 3% will come here. So 3% I'm going to provide. So this will be same as that 20%. Sorry, 20 mm diameter. So I'm going to provide 12 mm, 12 numbers. You see how 10, same 200, right? Yes. So then next you can see you have a column of 878. Let us make it as 880 and 60, right? 880 and 60. So this will be 880, this will be 60. So this I'm going to maintain as it is, and this will be 40 only. Yes, it is now again 0.28 and 0.04. 0.28. Okay, so it is yeah, 0.28. 0.28. 0.3 means this will be 0.28, and you have 0.04, which comes out to be very high value. 0.28. Why it is? Because 0.28. It is PU by FCK BD. The load is high. Okay. Yes, it is the load is high. So therefore let us make this as 400. Then it is 0.18 and 0.03. 0.18 and 0.03, which comes out to be 0.12%. Yes, it is come to be 0.12%. 0.12. So 3.6, 20 mm if I am providing. So I am going to get how many number of rods? 18. So let us make it as yeah, let it be there, we will see. Let us make it as 20 numbers. Okay, we will finalize the design later. Then I'm going to provide this. So I'm going to provide 200, right? So 13, 14, 15, 16, 14, 15, 16, 17, 18. Yes. So then next you have this column. You have 480 and 50, right? You have 480 and 50. So this I'm going to maintain this value. So 40 here, I'm getting 0.15 and 0.03. okay, 0.15, okay, 1 2 3 4 5, 0.15, and you have 0.03, right? Yes, 0.15, 0.03, which comes out to be, yes. So let us continue in the next video, learners. Since we have taken more time, we'll continue in the next video. Thank you.